Well, I have no idea what I'm doing.
If you felt anything like this on the AP Physics 2 exam, then this is dedicated to you. Let's start out with the million-dollar question. What even is a capacitor? A capacitor is simply two parallel conducting plates of equal and opposite charge separated by an insulator called a dielectric. This dielectric is typically air in the problems we work on in AP Physics 2. Of course, the definition is the easy part. What capacitors do and how they do it makes things interesting. The basic function of a capacitor is to store charge. When a battery is connected to a circuit containing a capacitor, the capacitor will begin to charge. This charge creates a potential difference across the plates, which allows the current to keep flowing through the dielectric. For this reason, current in a circuit with a capacitor will be reduced until the capacitor is fully charged. If the capacitor is charged and the battery is disconnected, then the capacitor will discharge all of its stored charge as a current, allowing the circuit to run until the charge runs out. Every capacitor has a value for capacitance. Capacitance is the ratio of stored charge to the potential difference between the plates. This can be expressed by the equation stating that the potential difference between the plates is equal to the stored charge over the capacitance. This equation can also be rearranged to state that capacitance is equal to the stored charge over the potential difference. Capacitance is measured in farads, which is the same thing as coulombs per volt. Now that we know what capacitance is, let's take a look at how a capacitor accumulates the charge that gives it capacitance. Recall from earlier that a capacitor must be connected to a battery to charge. As the current from the battery, which is just the flow of electrons, begins to flow through the circuit, these electrons will begin to accumulate on the negative plate of the capacitor. The negative plate is usually the first plate the electrons come to. The other plate will be positive because the negative charge on the negative plate forces the electrons on the positive plate to enter the circuit and join the other electrons on the negative plate. Once the capacitor is fully charged, which is when the voltage of the capacitor is equal to the voltage of the battery, then electrons will flow across the dielectric to the positive plate, and the circuit will run as usual. During this period, the capacitor creates an electric field in the dielectric. This field polarizes the molecules in the dielectric, causing a thin layer of positive charge over the negative plate and a thin layer of negative charge over the positive plate. For this reason, every dielectric has a value of K, the dielectric constant, which is always greater than 1 and varies directly with capacitance. A common use of capacitors is flash bulbs in cameras. The battery charges them, and at a push of a button, all of the accumulated charge exits in a flash of light. Now let's talk about equivalent capacitance. Just like other qualities of circuits, capacitance follows different rules depending on the type of circuit. In a series circuit, the reciprocal of the total capacitance is equal to the sum of the reciprocals of the individual capacitor's capacitance. In a parallel circuit, the total capacitance is the sum of the individual capacitor's capacitance. Here's an example problem. If a 2 picofarad capacitor is connected to a 10-volt battery, what is the charge? Let's start out by writing what we know. Next, we'll write the formula, then plug in the values given in the problem. If 2 times 10 to the negative 12 equals charge over 10, then the charge of the capacitor is 2 times 10 to the negative 11 coulombs. Here's a problem with capacitors in series and parallel. We need to find the equivalent, or total capacitance, in the circuit. We know C2 and C3 are in series with each other, so we add the reciprocals to get the reciprocal of the total, which is 1. The other capacitor is parallel to the series of the other two, so we just add them up and get a total of 6 millifarads. Now, let's quickly review the rules for finding total current, voltage, and resistance in series and parallel circuits. In series, current is all equal to total current. In parallel, individual currents add to make up the total current. In series, the total voltage is the sum of the individual voltages, and in parallel, the total is equal to the individual voltages. In series, total resistance is the sum of the individual resistances, and in parallel, the reciprocal of the total resistance is equal to the sum of the reciprocals of the individual resistances. Here's a simple combination circuit example. A combination circuit is just a circuit involving both series and parallel sections. Let's find the total resistance and current, and the individual values of current and voltage for the resistors. First, we find the total resistance, which is the 3 ohms added to 1 over the sum of the reciprocals of 4 and 4. Now we know the total resistance is 5 ohms. Using the formula voltage equals current times resistance, we can find the total current for the circuit to be 2 amps. Every resistor in series will have 2 amps as well, so we can now find the voltage of the first resistor, which is 6. Now we know that 4 more volts need to be accounted for to make the total of 10 volts. Therefore, both branches of the parallel section will have 4 volts. Using the voltage equals current times resistance equation, we can find the current in each resistor to be 1 amp. As a quick check, make sure that all the voltages add up to 10 and that the currents add up to 2. Notice, if we open this switch, then the total current would be 0. Now that you know the basics of solving a circuit, here's a challenge problem for you. Pause the video now and find the voltage and current values for every resistor, as well as the total current and resistance. Have fun! If you calculated these values, you were correct. Congratulations and thank you for watching.
Hon heter Anna, Anna heter hon. Och hon kan banna det så hårt. Och röjer upp i våran kanal. Jag vill berätta för dig att jag känner en bot som alltid vaktar alla som är här och som ser till att vi blir utan besvär. Det finns